I left off needing to install the exhaust and the steering cable and the steering setup, so I will get started on the steering now. Alright, so I've sorted the steering for the most part, but I'm still waiting on parts, so it's kind of just tucked along the lines here. Up the side of the gunnel, and then it's gonna hang a Larry and go right over to where the helm is. So I don't have my kit to install the helm just yet, so it's just gonna lay right there. I've also started sorting the wires and figuring out what I have to extend, and then got distracted, and now I'm working on the exhaust. So not a whole lot of organization this go around as I'm waiting for parts to arrive. So a lot of the wire placement and brackets all rely on the bulkhead, and the bulkhead position relies on the seat angles, and the seats aren't here yet. So kind of at a standstill, so just taking care of little stuff. So all right, well, I'm gonna start messing with the exhaust to figure out how I'm gonna get it out to the back of the transom. So here is that. All right, so I have the exhaust flange off of the manifold now, and you can see the water goes into here and comes out this little exit right here, and it enters into this cavity where there's a water channel or water jacket, the full circumference of the exhaust flange. And in there, you can somewhat see the light through the other side where these little holes pass the water through. So because this seals up against this, I'm just gonna mill a few reliefs into here to allow water to come from the inside of the circumference through to the inside right here, where it would ultimately end up back here anyway. But Yamaha does that for cooling purposes to make sure nothing gets hot whatsoever. But since we have a much larger space, I'm not too concerned about that. So once that's done, I need to lop this off and then turn this down on the lathe to 3 inches so that it will fit the new exhaust pipe and hose that I have that's coming, so that it can basically create a little P-trap or a water lock to the back of the boat. So I will get started on that right now. So I think I found a better way of doing this. I'm just gonna have to make a couple calculated cuts here, and then this is 2.65, and this is 2.75 ID and OD. So this will slip over here, and then I'll be able to weld this to here, go up with my water trap, and then exit the boat. So, and it'll look a little nicer. All right, so this is a little bit sketchy because it's not a balanced part, but I'd like to get this surface nice and straight, and then I also need to turn this down like 5/1000ths so that the aluminum pipe will fit. So hopefully I don't lose a finger. All right, so that looks a whole lot better now that it's been turned on the lathe. You can see how out of round this cast aluminum piece is, just based on the fact that it didn't get this side. But all I'm trying to do is get it turned down to where it will fit into this right here, and it does that. Actually, it's still a little tight, so I could probably turn that down a little bit further, which I'm going to, because I'd like to be able to move this around while it's on the boat and tack it together. And then once I have my final piece all tacked together, then I'll pull it out and put the final weld on it. So I'm gonna take another probably 2 or 3 thousandths off on this one. Yeah, something like that. Uh-oh. Might be a little too tight. But, yep. All right. Well, I just got to go figure out the position of the boat and then tack it in place. Alright, so something like that so far. And then once I finish it up, I gotta lop. I think I have to make another pie cut at like, it looks like it's probably a 30-degree angle to get that right there completed. And then once I have that, it should be pretty well situated. And then I'll just have a small section of flex pipe that goes to the back of the boat so that any shifting or vibrations, it has a little bit of give. So, but I think I'm probably going to reach out to my buddy Pat to make sure I don't screw this up, because he's a whole lot more versed with this stuff. So we'll see. All right, I will finish that up now. So that's the angle I want. So it's right at 40 degrees. So I need to make a 40-degree pie cut. I've decided I'm just going to do 2 20-degree pie cuts. And that should equal 40 degrees. So now I can clock this whichever way I'd like to kind of change the direction of the output. And it looks a little bit better with the bends. Whereas if I would have just done one, actually, if I would have just done one 40-degree cut, this is what the result would have looked like. It would have just been one hard, long, straight section instead of a little bit more of a radius. The guys that are good, they can do a whole lot more sections, but that is not me. Oh, that's terrible. Okay, something like this. So that's angled straight at the back. So once I get my 3-inch through-hole exhaust fitting, I'll use a small bit of rubber coupling to couple those together. So there's a little bit of ability for flex. Not that this should be flexing much at all, but, or I mean the motor. But yeah, just gotta compensate for a little bit because hard lines will break. It's not the greatest. You can definitely tell I'm not good at TIG welding yet. So I'm not certain I'm gonna try this myself. I might take it to Pat's house and have him show me what to do. But, or I may try it, who knows. I now have to take the exhaust flange off to mill those little reliefs, and then I have to weld each one of these little holes closed so that no water leaves the outside here and it follows through the inside channel instead of going to the outside, because that will just fill the boat. So I'll get to milling that now. So I'll likely just follow the same pattern of a little relief right there, a little relief right there, and a little relief right there, and then one at the bottom here to basically mimic where the holes let water out, so it can still retain the same level of cooling, I guess. But all right, here's that. So instead of trying to fill this entire hole with weld, I just turned this down to 240 thousandths, or the same as a 15/64 drill bit, which I think that's really 234 thousandths. So, but that's tight enough, and that'll allow me to weld basically and seal these up. So once those are sealed, then I'll do the little channels on the mill. So here is that. Something like that. Wowee. Okay, you can see each one of these little holes are now filled. I went through a few iterations of welding, turning down on the lathe, welding, and turning down on the lathe to get it to look where it is now, to where it kind of looks seamless. But yeah, have to grind basically everything I'm welding because it looks atrocious. But these should hold. So, and if they don't, then I'll just have to machine a plate to go around the circumference of this. Basically to plug all of this stuff and then weld all the way around it. But that shouldn't be high pressure in there whatsoever, just the pressure from the jet pump. So, all right, I'm gonna mill the inside of this. Okay, so that's basically what I was after, is just getting a means to get the water into this cavity. If it ends up being an issue with the way in which the gasket seals here and somehow water leaks by, then I'll end up just welding these back in and redoing this, where I drill the inside instead of milling channels. But I don't think there's gonna be an issue. So, all right, I'm gonna weld all this together and see how it works. All right, so the TIG exhaust turned out pretty nice. You can definitely tell I still don't know what I'm doing yet, but messing with the settings, I finally got it sorted. And it's parallel to the pump tunnel there, so that's good. So I still gotta wait for my through-hole fitting and the exhaust coupler to come in. So I'm kind of tabled at that point, or on this project for now. So I'm gonna move on to the trim. I do not want to use manual trim with this boat because style points, pushing of buttons, a lot easier. So I'm gonna reuse the electronic trim module out of the Sea-Doo boat that Austin didn't want to use. And but I think I gotta rebuild this motor or free it up or something, because it's, whenever jumping it to the leads on the battery, it does not spin. So I'm gonna take this apart and figure it out, and then build a relay configuration with a gauge setup and a couple limit switches, and get electronic trim, because I'm not going to use the VTS communicating module and all that, because that's pointless, and it's not a Sea-Doo boat, so it wouldn't work anyway. So all right, I will get started on that. All right, so I completely overcomplicated the whole trim situation. There is no communicating module. It's just simple voltages and resistance back to the trim gauge. So, and a polarity reversing switch. So whenever I energize green, that should push it, but there's a limit switch in there, so it's not actually energizing it, which is good. But if I do blue, it will retract the rod until the limit switch trips, and then it no longer works. But all the while, the resistance values for where the rod is at changes, so that I can actually use a trim gauge to know where it's at, rather than just blindly pressing up and down buttons and having no reference for where it's currently at. So I'll push it all the way out. So that has 39 ohms worth of resistance, so the voltage will be higher when it's returned to the gauge. Whenever it's all the way up, which would be pulled back, which would be lifting the nozzle, it would be 167 ohms, so less voltage. So yeah, all right, that's sorted. I will try and get this mounted somewhere. I don't know exactly how it's gonna work just yet, but it's already getting crammed down there, but I'll figure something out and try and make it not look like a dumpster fire. So here is that. All right, so this is the contraption I have set up here, and you can kind of visualize a plate that goes behind here that will adapt to here, and then this entire setup will get mounted somewhere discreetly in the boat. How this gets mounted discreetly, I don't know yet, but yeah, we'll try it. Anyway, so this is going to be a basically a class 3 lever, to where the fulcrum is on the opposite side from the load and the lever. So, or where the force is being applied. So the reason I have to do it this way is because this trim actuator only moves this arm 1.125 inches. So in order to get 2.25 inches worth of travel out of this cable, to move this bucket 2.25 inches to get all the rooster tail action, I need to do this setup. So basically, where this is right here, I have to do a bunch of sorting to get this thing to bolt up there, but that rod will go right there, and then that allows for the proper travel. So the trim motor travels 1.125 inches here, but the actual travel is 2.25 inches at the cable. So yep, that's gonna be the setup. All right, well, I'm gonna finish making this, because this needs something to bolt onto that holds it stationary against the trim motor and doesn't break this, because that's probably a lot of load. I could probably calculate the foot-pounds that need to be pushed on this to move this, but yeah, or Newton meters for the Europeans. But all right, well, I'll sort this now. All right, this is the contraption I have set up to use the Sea-Doo VTS motor that was laying around to actuate the trim nozzle. So hopefully there's not too much load on this arm, because it's a class 3 lever, and I don't think this was ever designed to handle that. But yeah, I'll just be aware of my throttle whenever I'm changing the trim position so that there's not too much load put on it. But here it is in action. So pretty neat. I do have to adjust the spacing on this right here and sort where it's going to go on the boat, because it's not perfectly right, because you can see it kind of bending up and down. But there's going to be a system up underneath the swim deck that holds this, and plastic bushings and all the works. So, or at least that's the thought process. So yeah, rooster tails. So all right, well, I'm gonna sort how that thing can possibly fit into the back of the boat here. So I will get to that. All right, so everything I did in the last 4 minutes was completely pointless, and the solution was terrible. All so that I could save like $20 for a linear actuator. So I realized that I was just overcomplicating everything for no real reason. So I made a new setup, bought a $20 linear actuator that has a travel of 2 inches, machined a 3/8 rod, and then built a little stand for it right here out of some just 1 1/4 inch pipe, and mounted it there. So this will push the bucket directly through a little through-hole fitting that I pressed an aluminum sleeve through with heat. So it's a plastic through-hole fitting. I just heated the aluminum sleeve up and forced it through. There's going to be a bellows that goes right, a bellow that goes right here that keeps it from, you know, keeps the boat from flooding. And yeah, so this is a whole lot simpler. And we get the trim needed to actuate it. So here it is in action. I still have to sort the polarity reversing switch and all that good stuff, but that's pretty straightforward. Voila! So that is sorted. I still have yet to finish the exhaust, so I'll do that in the next video. But this one's getting long, so I will cut it here. So that looks a whole lot better. Still a lot of work to do.